Hello and welcome back to the Brain Power Podcast. My name is Maxwell Hand and I am your host for this exciting journey. I thought I would try and surprise my listeners with 2 podcasts in 1 month. I know, pretty crazy, right? Don't really look at it exactly because the last episode was uploaded on the 31st of March, so it's not technically the same month, but give me a break here. I'm doing my best and I'm sure everyone out there is doing the same. So let's get ready to sit back and hopefully learn something new today. All right, let's dive right into it. I am a really big fan of change, and what better represents change than the changing of the seasons and the wonderful month of April. Spring is finally here. Yay us, we have some beautiful flowers, some terrible pollen, and this renewed energy in the air. You could almost say there's an electricity of some sorts out there. And funny enough, that's what today's topic is all about, electrophysiology. See what I did there? So, electrophysiology. I mentioned this term in the previous podcast, which you should totally check out, but I didn't really have too much time to cover it in as much depth as I would have liked. I probably left a few people a little more confused and looking for some more answers, so I wanted to dedicate one entire episode into explaining what it is. Hopefully all those people who were just waiting in sheer anticipation can take a nice fresh breath of air and get some of those questions answered. All right, electrophysiology. This is the study of electrical properties from biological cells found in your body. There's a few different kinds, but today I want to focus on the ones involving cells in your nervous system, most commonly neurons. So really quickly, I'll give you a really broad summary, and then I'll kind of go into depth and explain the different parts. So you have these individual cells in your brain called neurons. While these neurons are all by themselves, they are connected to other neurons through a junction called a synapse. There's a little connection between the two. There's a small little space between them that they can transmit molecules and different chemicals. But basically, when the first neuron is activated, or when it reaches a certain level, it's called an action potential. Now, this may cause the second neuron to also be activated, and when enough neurons are activated, this causes a domino effect in this small little series of cells called a neuron cluster. Now, when enough of these neurons are activated, it can be recorded on the exterior of your head with an electrode. Typically, we can find these electrodes being used in one single location or over the entire brain. And the whole brain mode of an electrode is basically referred to as an EEG, which is what most people have heard of. Now, let's hold up for a second before I confuse more people. I want to cover some of the common terms that we are using in the field. Then I will go over really how we're able to record and analyze the electrical properties coming from your brain. And finally, let's wrap up with how electrophysiology works in tandem with TMS. I think that's a pretty good introduction to electrophysiology and hopefully paints a decent picture about what's to come. So, what is an EEG? It stands for electroencephalogram. This basically translates to an electrical recording from your brain. There are a few different types of EEGs. The most common ones are just going to be wet EEG and a dry EEG. Some of these guys do require gel. This gel is really used to help increase the connectivity of the electrode and make your brainwaves pop. Some of them are pre-gelled, which is going to be dry. You won't really leave with gel on your hair. But some of them do require us to put gel into the little electrodes, and you may end up with some sticky goo. That's okay. A quick shower will fix all your problems. So there are a few different reasons we use either type, but I think it's more important just that you know what to expect if you ever go in for an EEG, and so you know what to ask next time someone brings it up. That about covers the EEG common term. Now I want to go over brain waves and what those are. These are different levels of electrical activity. They all come from your brain. Depending on your mental state, kind of what you're thinking about, what you're doing in the moment, your brain will be producing either faster or slower brain waves. On the very lowest end of the spectrum, we have delta. Delta waves are produced during deep sleep. So when you're snoring logs in bed, this is when delta waves are produced. They're very, very slow, very, very light waves. As we get a little faster on the spectrum, we have theta waves. This is when you're in early or light sleep, and a little bit faster, we have alpha waves. This one is an important one for us, so keep this in mind. I will cover it later on in this podcast. It's really important specifically for TMS at our clinic. Now, alpha waves are produced mainly during a relaxed and resting state, so you're not sleeping, but you're not really awake. typically with your eyes closed, is also where alpha waves are found. And then at the very, very, very high end of the spectrum of brain waves, we have beta waves. These are produced when we are active and awake. Now, the final term I want to cover is ECG or EKG. This stands for electrocardiogram. Either it's a K or a C depending on what country, but it always means a heart rate recording. It's important to notice this in today's podcast because some EEGs will actually incorporate your heart rate as an additional variable during an EEG recording. It's just something you might hear from one of the doctors you're working with, and so now you know. Okay, so I think both you and I can agree that this stuff is pretty cool, and maybe you know now more why I enjoy working with it. I think now you have a little window into what goes on behind the scenes. Speaking of what's actually going on behind the scenes, how are we really able to take these electrical properties, these electrical signals from your brain, put them on a nice clean computer for you to look at and for us to analyze? In a really simple explanation, we use these things called Eeg Caps. These Eeg Caps are basically a collection of different electrodes, either on a swim cap looking thing or a bicycle helmet, and they're connected to the computer either through Bluetooth or through a physical wire. And if all goes well, then we end up with a nice, clean recording. For this to happen, specifically at our clinic, we like to have you relaxed in a comfortable position with your eyes closed, and we hope to get between 10 and 15 minutes of nice, clean alpha waves. Now, this data doesn't really mean much in the computer until it's sent off for analysis. Typically, EEGs go for quantitative analysis, which basically means a clinician or a computer program combs through these thousands of waves and looks for averages in whatever specific area they want. So if you're looking for alpha waves, you're looking for the average of alpha waves across your brain, and then you can summarize that in a little report saying the average alpha wave is at this level, this many times, and at this rate. That's kind of how we're able to record and analyze what your brain's doing. Now that we have a pretty good background of electrophysiology and electroencephalography, I think the final question is ready to be answered. How does it all fit into TMS? As we already know, TMS, or transcranial magnetic stimulation, it can affect and interact with these electrical properties. I've discussed this in a previous podcast. Go check that out. There are a lot of these properties to really choose from. How do we know how to interact? Do we increase it? Do we decrease it? A lot of the research says that these alpha waves, what I mentioned before, which are produced during an eyes closed, relaxed state, they show a really solid correlation with several mental health and cognitive processes. Certain neurological disorders tend to show these disturbances in what's called the functional brain connectivity, and this connectivity is really distinctly represented or reflected in the rhythmic patterns of your brain waves, and most notably alpha. So that's kind of how we take alpha, and why alpha is important for us is because when alpha waves are not working properly, we see a correlation with less cognitive processes and more mental health issues. Now, it's not always true, but like I said, it's a correlation. All right, folks, in a quick little summary, we covered electrophysiology, we covered what an EEG is and how it works, we went through some of the different kinds of brain waves, and then we talked a lot about why alpha is important. But how does this really look in a clinic setting? When you are coming in for a treatment with TMS, part of the therapeutic process is to get this baseline EEG. Now, this is before you've gotten any treatments, and this is where we really determine any abnormal or irregular alpha wave patterns in your specific brain. These patterns really help us create a personalized protocol for your treatment, so we know where to stimulate, at how much intensity to stimulate, and what the best protocol or course of action is to take. The recording is also used actually for a measure of potential improvement. So typically across the entire series of treatments, we will do either 3 or 4 EEG recordings, and we can compare the individual ones from the first, second to the third, and you can actually see how your brain's improving over time with treatment. In this way, we can see if we need to adapt the protocol, change it, or just keep it on the same course, so we know that we're giving you the best possible treatment. All right, that was a lot, folks, and I am actually out of breath. Hopefully that helped you understand more about what electrophysiology does, how it works, and how it really relates to TMS and how we use it at our clinic. I would say that covers most of the important points of information for electrophysiology. Obviously, this is a really basic summary of a very complex technology, but I think we have made some good progress today. There will always be more questions to answer. That frustrates me, but also excites me. And there will always be more topics to cover, but that's also what makes this show fun for me. The excitement of covering new topics and helping more people learn. That about wraps up today's podcast, everyone. I hope today's show has really helped you learn something new, maybe even inspired some of your own questions. Like always, if you have any questions, comments, or suggestions, either positive or negative, I would love to hear from you. It is really important for me that my listeners are also a part of this journey as much as I am, because at the end of the day, this is because of you. I'm doing this podcast to help people who are listening. If you want some more information, definitely look up our website at www.brainstemcenters.com, and I look forward to hearing from you. I will see all of you on the next episode. Thank you for everyone who stopped by to listen in, and I hope you have a wonderful rest of your day.